Well, hello everyone. Bivariate statistics, which you have been doing for all this term, is now finished. Apart from handing in your assignment, we're now on to the second of the three parts of this course, which is number sequences. So, new stuff to get your head around. The official title of the chapter is Number Patterns and Recursion, and all that will be explained as we go through it. So in this chapter you will learn about number patterns that are for operations rule based. I'll be explaining what that means shortly. And you will be describing these rules as either recursive or as arithmetic or geometric. For operations are adding, subtracting, multiplying and dividing. So we're going to use one or more of those operations, adding, subtracting, multiplying or dividing, to create number patterns. So there's your learning intention. Can you generate sequences using a calculator? That could be either a scientific calculator or a graphics calculator, and describe the terms of a rule-based sequence using subscripts. Now we're actually going to do that the other way around. So first of all, I'm going to describe terms of a rule-based sequence using subscripts, and then we'll talk about generating sequences of numbers on a calculator. Well, there are two types of sequence. There's a randomly generated sequence, such as 3, 1, 2, 5, 6, 16, 43, and being randomly generated, it should be impossible to say what the next number is. And there are rule-based sequences such as 1, 5, 9, 13, 17. Think about it, and we'll come to that, back to the answer in just a moment. First of all, just let me mention that these three dots are called a horizontal ellipsis, and they are a way of saying that the sequence goes on from whatever you've seen there. So what was the rule for that one? I hope that you can see that each number is generated by adding 4. So obviously the next number is 21, and then 25, and so on. We're only obviously going to be interested in rule-based sequences in this course. Going back to that previous slide, we generated the next number in that sequence by looking at the last number. So 21 is created by taking 17 and adding 4. Now, sequences generated like that are called recursive sequence because each number depends on what the previous number was. With a recursive sequence, you could not be able to easily tell me whether 121 is in that sequence or not. With arithmetic and geometric sequences, which we deal with later in the unit, you will, but with a recursive sequence, you can't. All you can do is generate the next number from the current number. That's called a recursive sequence, and you're going to have to learn the language of writing recursive sequences, which starts like this. The first term in the sequence is T1 with a subscript 1, and the second term is T2, T3, and so forth. So that's what's in red there. If I ask you to calculate T31, that means find the 31st term of the sequence, whatever you're looking at. Which one of these numbers, 1, 5, 9, 13, 17, is T4? Well, I hope that you've got that it is 13. That was a sequence generated using addition. Other sequences are generated with a rule that involves multiplication, division, or subtraction. What's the first one? 5, 8, 11, 14? It's another addition one, isn't it? 66, 58, 50, 42. I hope you see the numbers are going down, and they're going down in eighths, so that one is involving subtraction. 128, 64, 32, 16, and so on. You should be able to tell me that the next number is 8 because each time you are dividing by 2. Let's have a look at a multiplication one. Let's say the first term is 5 and the multiplication rule is times by 2. So the next one will be 10. Next number, double it again, 20. Next number will be 40, and so on. That is a multiplication rule. This was addition. This is subtraction. This is division. The rule for the addition one was add 3. The rule for the subtraction one was, the rule for the division one was divide by 2, and the rule for the multiplication one was times by 2. Other sequences can be generated with a rule that involves, say, a multiplication or a division, and an addition or a subtraction. Look at this one, 2, 12, 42, 132. Now if I can remember where that sequence came from, I think what I did was that I multiplied by 3 and then added 6. Let's just check if that was right. 3 2s are 6 plus 6 equals 12. 3 12s are 36 plus 6 is 42. That's worked so far. You should always check a sequence works with all the numbers you've been given. 3 42s, 126 plus the number 6 makes 132. So the rule here is times by 3, then add 6. Now you will learn later in the unit how to discover that that rule there is multiply by 3 and then add 6. Oh, it's on the screen, jolly good. If you want to generate a sequence on your scientific calculator, a recursive sequence, it's quite easy. Let's look at scientific calculators first and then graphics calculators. Put your number into the, very similar, the two calculators. Put your number in first, get your calculator ready, put a 6 into it and press enter. And then you can type the rule by going times 3 plus 4. And press enter to get the second number, which is 22. All you've got to do is press enter again and it should give you the third number, 70. Now I suggest you pause this presentation and try that on your scientific calculator. When you're ready, get a graphics calculator out and do much the same thing, slightly different. You put your first number in, 6, and then press enter. And then the rule is you have to press the answer button, which I think is down on the bottom right of your graphics calculator, and then type 3 plus 4, enter, and then enter and enter, and you should get the same sequence of numbers. Pause this presentation while you make sure that you can do that on your graphics calculator. And there you have it for 4a. After listening to that and practicing the exercise, you can say you can generate sequences using a calculator and describe the terms of a rule-based sequence using subscripts. Rest of the lesson, please. Headphones off unless you want to watch this again. Exercise books out. Exercise 4a is on page 100. Explore all of the questions and so that you're ready for 4b on the next presentation.